74 CloudFormation stacks, 462 IAM permission changes, all from upgrading AWS Landing Zone Accelerator in a lab environment with just 5 AWS accounts and no real workloads. In production, you're looking at potentially hundreds of changes across dozens of accounts. And if you miss one critical IAM modification, you could potentially lock workloads out of essential services. So if you approve a network change without understanding the impact, you could potentially break connectivity to on-premises systems. When you upgrade LZA, or Landing Zone Accelerator, do you spend days going over the logs, or do you upgrade and pray? Hopefully, I have something better. For those not familiar, Landing Zone Accelerator is a tool by AWS that automatically sets up a secure, well-organized, and easy-to-manage cloud environment in AWS, making it simple for organizations to get started and stay protected as they grow. In this video, I'm showing you an AI-powered tool that cuts hours of manual log review into minutes of actionable intelligence. Note, though, that this is still a work in progress. However, I've decided to present on this, although it is still in development, so that I can understand it better and get more insights in order to make further improvements. Let's dive right in. You can see a sample of this upgrade analysis report and how, with the help of AI, I've built the LZA diff analyzer, a Python CLI tool that combines rule-based analysis with large language model intelligence. Here's the architecture. The system uses a hybrid approach. So from the top left here, it first reads all the diff files, parses through the files, then uses a hybrid approach for rule-based analysis, having specialist analyzers so that they can focus on their particular categories of security, network, operational compliance, and so forth, and also leveraging on LLM for contextual analysis and business impact assessment. Using the tool is as simple as running this command. Let's just go and run the Python virtual environment, run UV-sync to make sure we've got all the packages installed, then run the command LZA analyze in my input directory. Then I will make it generate reports. Okay, so automatically it is using the AI, which in my case, at this stage of my development, it's using the local Olama client where it's defined in this LLM config YAML file. And as you can see, I've tried different models in my local Olama server. At the moment, I'm using DeepSeek, and I've also played around with the different token sizes for the context size. It's finished its analysis. It's found 74 diff files. It parsed through all those files. It used AI to enhance the analysis and starts off with an executive summary telling me that the version upgrade from this to 1.12.1, it detected 225 resources, 462 IAM updates, gives me a summary of the assessment saying that it's high. Also gives me the business impact assessment that it's actually medium. It tells me what the security posture is, what access controls and permissions. Then it also gives me a list of there's some strategic recommendations, there's immediate actions, strategic recommendations, context, a risk assessment, a technical reference of the table, and it gives me an option to interact with the AI assistant to further drill down on specific IM changes or questions I might have. So let's say yes to that. But while it's doing that, see here, it's generated this HTML report. If I open this HTML report in my browser, here's the HTML report. It gives me a much friendlier presentation of its findings. See here, the key for me is, in spite of the number of changes that it's made, because of the AI enhancement, it's made this assessment that this is actually a normal upgrade volume, that the number of resource changes that I see here is normal for this kind of upgrade. Although it's pointed it as high because in the code, I have said that if there's IM changes, if there's network related changes, that they be categorized as high. That's because I specifically defined these resource categories as risky. I want to be flagged of potential breakages in being able to access my production workloads in terms of the network access being broken because there's this dependency of my workload in the cloud to access certain components on-prem, and that is dependent on the transit gateway components, the direct connection. So any of those types of changes that can potentially impact my workloads, I want to be told about. So basically, it's telling me that it's got all these changes, but it's normal and it's fine to go on with this. This is another important part for me, is that it highlights the particular logs that I should be paying attention to, because there are all those IM or network or security changes that it's picked up on. So if we open one of them, the AWS Accelerator logging stack starting in 537, expand that, you can see there's quite a lot of resource changes happening here. Let's pick on one of these changes. Line 21 says that it's creating a new permission set over this resources, the central logs bucket, giving these permissions, giving it to this principal with an AWS star with this condition. So for example, if we ask the AI assistant about this, can you explain? And it's actually timed out. It errored out with a too large or system is under load error, because this is the first time I'm trying DeepSeek R1 with that new context size as well. So if I quit this, change to Quen, change it to the smaller context size, run it again. And this time I'm gonna skip the comprehensive analysis because I already have that. Interact with the AI assistant. Just copy that same question I gave it. Okay, so it's finished its analysis. I made it show its thinking so I can see how it's going about with its reasoning. Well, it's assuming that this is the file that I'm referring that line from, which is wrong because it starts with 573. But it's made some assumptions that I think it's correct. It's made these key findings that these actions, which is just read permissions over such resource, and that the principal AWS with a wildcard, although it's followed by this condition, this AWS principal org ID, it's saying that it is a broad principle, but if you can check that the condition limiting it to the principal org ID is what you're expecting it to be, which in my case it is correct, then for me that is an acceptable risk. And for me, I'd like the AI to tell me that it thinks it is high risk for now because I don't trust it. Let's ask it again. Another question. How do I test these changes? These are just the sample questions. Okay, so it's done. And it's given us quite a long list of findings. I ask it, how do I test these changes? It says prioritize the IAM changes first, and it lists down 16 files as the files with IAM changes, telling me, look at these files first, validate the resource changes, that those 225 resource changes across all stacks, are those fine, and the permissions changes on those resources, is it okay? And lastly, the key recommendations is to look at those IAM changes and isolate and test those stacks with the most changes in a staging environment, which normally I can't do. Audit the version updates for compatibility, even if they are labeled as version only. Let's now go into understanding what happens under the hood. I'll just show parts of the code because it is quite a long code and a complex one with multiple modules. Let's focus on the core challenges. Let's start off with the parsing and how the parsing helps in the analysis stage. Let's open one of these log files. You can see that the CloudFormation diff logs are designed for human consumption. It's structured in a way that it's easy to spot what resources are affected, what is being done, whether it's being allowed, and what particular actions is being or permissions are being given over which resource and to whom, what is the principal, and if there are any conditions in JSON format. So these ASCII tables with box drawing characters, multi-line JSON conditions spread across table cells are formatting that's perfect for our eyes, but it creates noise for AI processing. And that's why I chose this hybrid approach of rule-based analysis, providing for that consistency. The same risky IAM pattern gets flagged every time, and LLM analysis providing the context. LLM is made to understand how those IAM changes affects the overall security posture. If we look at the analysis engine in the source directory under analyzers, the analysis engine, this is the main coordinator or orchestrator orchestrating the rule-based analysis outputs and combining that with the outputs of the LLM, where it creates the changes summary, where this method creates a changes summary for the LLM. Instead of sending the raw ASCII tables, it gets transformed into the log file name, followed by the summary of how many stacks, how many resource changes, key changes by categories. So all these transformation that the symbol, the plus symbol means adding it, this symbol means modifying, and the minus symbol means deleting. So giving this context to the LLM, making it understand better by giving it these contexts, the diff files by content type. So all these summaries are provided for it so that the LLM can focus on the types of implications instead of parsing the table formatting. Let's look at the base.py file. When it's analyzing infrastructure changes, we need consistency. There's this base risk analyzer template that defines what the pattern is for each type of analysis, whether it's a security related risk, a network risk, or a compliance risk. It is following some sort of a checklist that this is the finding, these are the sections of the finding that it should have, that there should be a title, a description, risk level, stack name, impact description, and so on. If we look at one of the specialist analyzers, like our security analyzer here, this defines for us that the wildcard star refers to admin and root access, IAM star, STS assume role with SAML. It defines for us that this is high risk. It also defines for us that these are sensitive resources. So if you detect this pattern of an AWS IAM : role, then it is potentially a sensitive resource that you're touching. This security analyzer is a specialized analyzer on security patterns. It has these hard-coded high-risk IAM actions that immediately it triggers alerts, and no AI is being used in this part because they are well known, and rule-based detection is faster and more reliable. Going back to the analysis engine, the section here is where rule-based analysis meets AI intelligence. The analyze with LLM method doesn't send the raw logs, as I said. It sends the structured, categorized data about what changed. Looking at the base Python file under the LLM directory, this is the LLM provider abstraction that supports multiple LLM providers: Ollama for local inference, OpenAI, Anthropic. But at this point in time, I'm only using Ollama. As you can see, I only have the Ollama client created, with the future plans of integrating and giving the option of using OpenAI and Anthropic. So this pattern lets me switch between providers at runtime with automatic fallback. I'm gonna switch back to the analysis engine and show you the LLM prompts that we have. The prompts are specifically engineered for AWS landing zone accelerator context. Notice the critical constraints here from lines 235 to 239. I had to put them in place because I noticed the AI was giving me made up outputs. It was making a lot of hallucinations and pulling its analysis from different data that it's been trained with. Needed it to constrain its analysis on the log files that it's been given it. So I've learned while developing this tool that it's quite challenging to make AI work reliably. And in an enterprise environment, mostly correct isn't good enough when you're reviewing changes that could affect production workloads. So there's a lot of error handling that I've had to introduce here, and some fallbacks with the help of AI, of course, in guiding it and prompting it to consider these things and questioning it while developing this with this tool. This project has taught me so much. It's been quite an educational journey for me. Let me share some of the lessons I've learned. One of them is that AI tools, especially for what I'm trying to achieve and to put it in an enterprise environment for infrastructure automation, I think I need to be really careful and make it pessimistic by design. When I'm reviewing changes that could affect production workloads, probably correct is not going to be good enough. Even with AI analysis, I still need to review and validate recommendations. The human is still the slowest part of the pipeline, but that's by design. The tool accelerates my analysis, but it doesn't replace my judgment. Despite the pre-processing, complex multi-stack dependencies can still overwhelm context windows. The solution isn't bigger context windows, it's smarter data preparation. So I've got to think of a way of packaging these logs to become more friendly to the LLM. For my planned enhancements or improvements in the future, I want to explore using RAG, Retrieval Augmented Generation. There's semantic indexing that I want to try. Instead of trying to fit everything into one prompt or just giving it a summary, I want the LLM to be able to have at its fingertips access to these log files in the format that it can easily understand. I also want to try multi-agent validation, thinking to myself, why have one AI analyze the logs when I can have a second AI challenge the first one's findings? Like having a senior review a junior's recommendations. I'm planning a validation agent that questions recommendations and provides additional perspectives. To recap, this tool successfully processed 74 of these stacks, identified 225 resource changes, categorized 462 IAM modifications. And how do I know that? Through this summary table that is generated as an output. Most importantly, it changed my relationship with LZA upgrades from dreading them to having more confidence in planning them. This project has taught me that the intersection of AWS infrastructure automation and LLM capabilities opens up approaches I had not considered. But the key insight for me is reliability trumps complexity. The AI can be brilliant a lot of times, but if it fails when I need it the most, it's worthless to me. That's why I think it needs that fallback systems of having the program rule-based analysis as a backup if the AI is not available or is not able to provide any outputs. The code base is available on GitHub. The link is in the description below. And if you're building AI tools for infrastructure, I'd love to hear about your approach. Until next time, keep building, keep learning, and remember, the best way to understand AI is to build with AI.